Hi there. Have you ever taken the time to have a little think about such a simple thing as the angle? So here we are, an angle. Now the thing about an angle is that if we stand here, we get a bit of a distance from there to there. Now that might be, I don't know, a couple of meters. But then if we come back here, we can see that that one there, say this one was 2 meters, this might be 1, 2, 3, 4 meters. But it's still the same angle. The angle hasn't changed. And so on. And if we go down to here, we put a line in here, still the same angle, but way much bigger difference. So let's say we get a little bit scientific about these things and we say, well, we'll make these right angles here, because that, to measure it nice and straight and keep it all the same. And we can see that although we've got the same angle, we're getting these different distances. But the thing about this is, the thing about the angles, it's not so much the angle itself. The important factor to consider here is the ratio. The ratio. That's very important. And what man found in the olden times was that it's the ratio, that this distance here, say for instance, well, I don't know, say here's our angle here, right in here like that, just there. And we've got this side here sort of opposite the angle. We'll call that the opposite side. And then we've got this side here, it's sort of one of the legs of the angle. We might call that the A for adjacent. So let's say for instance here we've got O for opposite. Okay, and we're calling that the O. And then we've got adjacent, A for adjacent. I'll use adjacent, AD. JACENT, A for adjacent. Now, they sort of had to come up for a name for this side here, and after much deliberation they decided to call it the hypotenuse. I don't know why. But it's called the hypotenuse, H. Now, admittedly here we're talking about right-angled triangles, so it's very important that these ratios will apply, but you can see why we might want to deal with those. They apply to the right-angled I'll just use a little triangle symbol for my triangle here, to the right-angled triangle. Alright, now what they found is that these ratios, providing the angle stayed the same, and so here we'll call this one O dash and this one O double dash, and then we can see that our H's, as we get a bigger H out here, like that would be H dash, and right out there would be A dash. So I think you get the picture, getting the picture here all right. So what they decided is what they had these ratios, and they knew that they were the same, like that O over A in the small triangle equaled O dash over A dash, which equals O double dash over A double dash. The ratio was the same. And similarly, if we took, for instance, O over H, that would equal O dash over H dash, and it would equal O double dash over H double dash. So it didn't matter how far away you were from the angle, these ratios were the same. And similarly, obviously there's three elements here. We could have A over H, and that would equal A over H dash, A dash over H dash, and A double dash over H double dash. The double dash coming from the larger one out here. Now they measured them very carefully, and they could see that these ratios were all the same. And then they said, well, hang on, we'd better give these ratios a name. So indeed they did. They decided, had a bit of a meeting, I suppose, and they decided that they would call the opposite over the adjacent, that would be known as the tangent. The tangent of the angle. And then they said, well, the opposite over the hypotenuse, we'll call that the sine. And the adjacent over the hypotenuse, well, closely to the side, we'll call that the cosine. I don't know when they decided this, but whatever. So there we are. We have these ratios, and the ratio is constant, so they're constant ratios. And this is the thing. For each angle, as long as the angle stays the same in a right angled triangle, the ratio will stay the same. And then we give the ratios a name, and there you go. Now then it came to pass that they decided, well, we could accurately measure these ratios, so they could say, well, if we know what the ratio is, let's say that the sine of some angle, well, hang on a minute, we need some way to measure the angles. So how could we measure the angles? So that's when they decided, oh well, what we'll do is we'll take a circle, and that'll give us all the angles. Now what we'll do, and then why they did this, we'll divide the circle up into 360 degrees. 360. So that means that if we divide the circle into 4 equal parts, each one of those will be 90 degrees. 90, 180, 270. And then we can divide each of the degrees. So we've got 1 degree equals 60 minutes. And 1 minute equals 60 seconds. So they had to come up with a system for measuring the angles. So they used this 360 degree thing. So then they found out, well, let's say if we have the sine of any angle, we'll call it the sine of angle A, sine A. Okay, Now that's a ratio. Remember, that equals the opposite over the hypotenuse. Sine of A equals the opposite over the hypotenuse. So what they did was they went out and worked out and measured. They carefully got there and worked out what that equals. That equals a ratio. The sine ratio. Okay, so then they worked backwards. They said, well, hang on. If we know the ratio, and we know and one side and one of the sides, if we know the ratio and one side, we can work out the other side. See, they were pretty clever, these dudes. They worked out that using the properties of the angle and the constant ratio, that if then they worked out what the ratios were, if they know the ratio on one side, they could work out the other side. And if they knew both sides, they could work out the ratio. And if they work out the other side, not the other side, they could work out the other sides. Now this all occurred quite a long time ago, and now we find where we are, here we are today, that we have all this information and we can learn it quite quickly. And so on our calculators we have the ratios. Breaking news. These ratios, breaking news. These ratios are available to all. So here we are, back here, just taking some time to think about an angle. We can see perhaps how through time that man was able to develop some of these marvelous mathematical things that we have available to us today, just based on some simple observations of angles, things that we take for granted. Now we have all the ratios available, so provided in any right angle triangle, provided we know two facts about that triangle, either the angle and one side or two sides, provided we know those facts, we can work out everything about that triangle. And that, whereas in the old days that knowledge was quite powerful, today it's available to us all. So think hard about the angle and where it's come from and what it's achieved, and how we can now take it forward and use it in our everyday work as perhaps surveyors, carpenters, electricians and whatnot.